Okay, so for the first one, first thing we have to do is figure out how they combine. When we're dealing with negatives, even though it may say subtraction, sometimes we're adding, sometimes we're subtracting. So when we're subtracting, of course, we change it to plus the opposite. So 3/4 minus a negative 1/6 is going to become 3/4 plus the opposite of negative 1/6 is positive 1/6. So now it's just a matter of finding our common denominators. 3/4 plus 1/6. What's our common denominator going to be? 12. What's this going to become? 9. 4 times 3 is 9, so 3 times 2 is 9. This will be 2. 6 times 2, so 1 times 2. And now we are adding because subtracting a negative became plus a positive. 9 and 2 makes 11 and 12. How many of you got 11 12 for that one? How many did it with a calculator? A couple of you. Okay. Well, that's good. As long as you figured out how to do them on the calculator, that's great. This one here then, negative 1/3 divided by negative 3/5. Well, the negative 1/3 isn't going to change, but it's going to be times negative 5/3. We take the reciprocal of 3/5. Notice the negative doesn't affect the reciprocal. It just stays out in front of the fraction. Now we have a negative times a negative, which means the answer is positive. 1 times 5 is 5. 3 times 3 is 9. So positive 5/9. Any questions? Okay. So that's pretty much it for the fractions. Yesterday in class, we were dealing with converting standard numbers, decimal numbers into scientific notation, and then scientific notation into standard numbers. And we dealt with a lot of powers of 10 and stuff like that. So let's do just a little bit of review. First, if I have the number 46 million, how am I going to convert that into scientific notation? Well, in scientific notation, it's going to become 4.6 10 to the 7th. Good. The decimal point's right here. We're going to put it here. It has to go 1, 2, 3, 4, 5, 6, 7 places. We know it's a positive 7 because this is a large number. It's in the positive place values. This one here, to change it into scientific notation, it's going to become 8.3 times 10 to the negative 5. Decimal points here, we want it here. It's 1, 2, 3, 4, 5 spots. We know it's negative because this is a small number. It's in the negative place values. And of course, going the other direction, we could have 2.9 times 10 to the negative 6th. Is this going to be a small number or a large number?
Small.
Small because it is a negative place value. So we're going to take the decimal point and move it which way? Right or left?
Left.
Left. 1, 2, we got a 0, 3, 4, 5, 6 places. So that is 0.0000029. By the way, when I do my decimals, I leave a space every 3 decimal places. It's just a habit. Helps me keep track of stuff. Something you might notice in some of your math, I don't remember if this text, I don't think this textbook has done it yet, but a lot of your math textbooks have started doing, they don't use commas in numbers like this anymore, 46 million, they just write it the same way, with like an extra half space, not using commas. The reason for that is that there are some countries that don't use a decimal point. In some countries this year, 0 point, that would be, they use a comma. So because of that, it's caused some confusion when we use a comma for separating every 3 places for large numbers. It's caused some confusion with other countries because they use a comma instead of a decimal point. So some of our textbooks have stopped using commas and just use that extra space for large numbers too. Just so you're aware. So how about 9.1 times 10 to the 5th? What's that going to become? Well, is this a large number or a small number? Large. It's positive. Power of 10. So it's going to be large. So my decimal point has to move how many spots? 5. Left or right? The right. 1, 2. We got a 0, 3, 4, 5. So that is 910,000. Well, some of the other things we did, we worked with those powers of 10. We had 10 to the 8th times 10 to the 7th, which is going to give us what? 10 to the 15th. We added, when we're multiplying exponents, the shortcut is that the powers are added. So 10 to the 5th times 10 to the 9th is going to be 10 to the 14th. When you're multiplying the exponents, you add the powers. We'll try one more. How about 10 to the 7th times 10 to the 12th? 10 to the 19th. There we go. How about 10 to the 8th divided by 10 to the 5th? Well, that became 10 to the 3rd. When we're dividing exponents, the appearance is that the powers are subtracted. 8 minus 5 is 3. So 10 to the 12th divided by 10 to the 4th is going to give us 10 to the 8th. Good. 12 minus 4 is 8. 10 to the 23rd divided by 10 to the 19th is 10 to the 4th. Good. How about when we had 10 to the 7th to the 3rd power? When we're taking a power, an exponent to another power, what do we do with those powers? Multiply them. This is 10 to the 21st. 7 times 3 is 21. So 10 to the 8th to the power of 9 is going to be 10 to the 72. Good. How about 10 to the 5th to the power of negative 4? 10 to the negative 20. Good. 10 to the negative 3rd to the negative 7th. 10 to the 21, right? Negative 3 times negative 7 is a positive. Negative times the negative is a positive. 3 times 7 is 21. These were the easiest ones to put the negatives in because you're multiplying. You're just multiplying the numbers and you just have to figure out whether the power is positive or negative. But if I had 10 to the negative 5th times 10 to the 3rd, what's that going to be? Well, negative 5 plus 3. You got negative 5 plus 3. It's going to be negative 2. 10 to the 7th times 10 to the negative 12th. It's going to be 10 to the, well, you got 7, negative 12, negative 5. 10 to the negative 5th times 10 to the negative 8. Got negative 5 and negative 8. That's going to be 10 to the negative 13th. Or 10 to the negative 5th times 10 to the 12th is going to be 10 to the negative 5, positive 12, 10 to the positive 7. Those aren't so bad. Adding with negatives, adding with integers isn't terrible. The ones that really kind of got confusing were these. 10 to the negative 4 divided by 10 to the 8th. That is negative 4 minus 8. And remember, we changed that to negative 4 plus negative 8. So negative 4, negative 8 makes 10 to the negative 12. Or 10 to the 5th divided by 10 to the negative 3rd. That's going to become 5 minus negative 3 is 5 plus a positive 3, so it's 10 to the 8th. Very good. Those negatives still look confusing? No. I'm sensing a little sarcasm there.
Oh,
No. 10 to the 7th times 10 to the negative 4th over 10 to the 9th, the power of negative 4. What would we do with something like this? Okay, so we got to do the top first. 10 to the 7th times 10 to the negative 4 is 10 to the 3rd. Yeah. Positive 7, negative 4, it's going to be the positive 3rd. So then you've got 10 to the 3rd divided by 10 to the 9th. What's 3 minus 9? Negative 6. And now the negative 4th. This is the easy part. Negative times the negative is positive. 4 times 6 is 24. So you get 10 to the 24th. Okay, where do I start here? On the bottom. What do I get down there? 10 to the 6th. Very good. 10 to the negative 3rd times 10 to the 9th. Since we're multiplying, the powers are added. Negative 3 plus 9 is 6. Everything else stays the same. Then what? We're going to divide. 10 to the negative 5th divided by 10 to the 6th is 10 to the negative 11. Negative 5 minus 6, or negative 5 plus a negative 6 is negative 11. And then 10 to the negative 11 to the 3rd. Power of a power means we're going to multiply. What's negative 11 times 3? Negative 33. So negative 33. I'm going to have you guys try a couple of these in your notes. Let's start out with this one. Try that one quick. Let's get the first step out of the way. We're going to do the top and the bottom. 10 to the negative 5 times 10 to the 7th is 10 to the 2. Negative 5 plus 7 is 2. And on bottom, 10 to the 8th times 10 to the negative 12 is 10 to the negative 4. Anybody need more time to finish it up from there? No? Okay. So, then we're going to divide. 10 to the 2nd divided by 10 to the negative 4 is 10 to the 6. 2 minus a negative 4 is 2 plus 4, or 6. And then finally, 10 to the 6th, the power of negative 5 is 10 to the negative 30. How many of you got 10 to the negative 30? Few? Everybody else see where they went wrong? No, do you know what you did wrong?
not really.
Did you have it to this point? Okay, so it's when you're dividing, the subtraction is getting you. 2 minus a negative 4. Because when you're dividing, you're going to subtract the powers. You got to change that to adding the opposite. So it's 2 plus, the opposite of negative 4 is positive 4. So 2 plus 4 is 6. So you use your 10 to the 6th when you divide those two. So now you still got 10 to the 6th to the power of negative 5. And when you have a power to another power, you're just going to multiply those two. So 6 times negative 5 is negative 30. Make any sense?
I think it's just going to take some time to soak in.
Okay. Let's give you another one to try in your notes. Hey, somebody caught it. That actually can be done, but it's all to the power of 0, which means it's 1.
I just explained it to my girlfriend yesterday.
Yeah?
She's just like, no, she's like, 0? I was like, I thought it was 0 too.
Since the whole thing's to the power of 0, I mean, you could do all this calculation if you want to. Anything to the power of 0 is 1. Always.
Well, it's not multiplication.
No, it's to the power of 0. Remember, we went over that yesterday?
Yeah, but it didn't make sense to me yesterday.
Yeah. Think of your place values in your number system. You've got the hundreds, the tens, then you don't have the zeros, you have the ones. This is the 10 to the 0, 10 to the 1, 10 to the second place values.
I guess I should understand it.
What would be the answer to
What if
that?
somebody forgot, you know?
Yeah, well, that was good. I like that.
What would be the answer to that if it wasn't a 0?
If I took that 0 off and put a different number up there,
Yeah,
then it would take a while to get there, but you could get there. Yeah, you'd have to pick away. You'd have to do this piece, then this piece, then you have to combine them. Then you have to come down here, do this, then combine those, do this, then combine those, then combine those, then combine those.
Take like 5 minutes.
It would take me a few minutes to do it, yeah. I don't hate you guys enough to make you do that, really. Yet. Okay. So let's get on a serious note here. Why is it that we have worked with those powers of 10 like that yesterday and today? Well, because in our scientific notation, we can do operations with our numbers. And that's what we really want to look at for our new topic today is operations with our scientific notation. A little bit of review when we add or subtract. There are 2 rules. Rule number 1 is we must have the same name. And rule number 2 is we keep the same name. So for example, if we had 8 inches plus 3 inches, we get 11 inches. We have to start out with the same name, and we keep the same name. What do you want to ask, Heather?
I said, isn't the name the numerator, or is it the denominator?
Well, in a fraction, it's the denominator, the bottom. The fifths or the sevenths or the eighths, that's the name. Yeah.
Okay.
Yeah.
We can't like, well, you can do 8 inches times 3 inches, right?
Times 3, yeah.
You can do like 8 inches times 2 yards.
You could, yes.
You just combine them?
When you're multiplying, you can.
Like, what would it be, like a yard inch?
Yeah, there's a yard inch. It's actually is a unit. We just don't use it much anymore. A yard inch or a foot inch. If you want to do inches times feet, is just a foot inch is a unit that's 1 inch wide by 1 foot long. It used to be used a little bit more, but it's not so much anymore. Or an inch foot actually is what it used to be called, not a foot inch. But so yeah, when we add, we must have that same name, and we're going to keep the same name. Or we had like with fractions, it was 2 sevenths plus 3 sevenths. We had to have the same name. We combined the counts, 2 plus 3 is 5, and we kept that same name. When we had larger numbers, like 436 plus 218, it doesn't look like there's names here, but where were the names? The names were in the place values. This is the 6 ones. It's going to get combined with the 8 ones. This is the 3 tens. It's going to get combined with the 1 10. This is the 4 hundreds. It's going to get combined with the 2 hundreds. So our names in most of our numbers get hidden in the place values. But when we add or subtract, that's why we have to line up the columns, is so that we're only combining the same names. And we add or subtract straight down so that we're keeping them in that same column or keeping the same name. In scientific notation, then, what part of the scientific notation is the name? Well, if you think here, what part of the scientific notation is implying a place value? The 10 to the 8th. We looked at our place values yesterday. 10 to the first is the ones, 10 to the 1 is the tens, 10 to the second is the hundreds. The 10 to the 8th is actually the 100 millions. So when we add or subtract numbers in scientific notation, we must have the same power of 10. So let's take 4.2 times 10 to the 8th. Now we've seen with our negatives that sometimes we have parentheses around stuff. It's not telling us to do anything there first, it's just separating the number. Same here. The parentheses are not telling us that we have to do anything inside here first. It's just separating the 4.2 times 10 to the 8th from 3.9 times 10 to the 8th. Just like if we had negative 6 plus negative 4, the parentheses would separate the negative 4. So here, do we have the same power of 10? We sure do. And when we add numbers, we combine counts. 4.2 plus 3.9 is 8.1 times 10 to the 8th, because when we add numbers, we keep the same name. So 10 to the 8th and 10 to the 8th will stay 10 to the 8th. So we might have 5.3 times 10 to the negative 7th plus 2.4 times 10 to the negative 7th. They have the same name, so we can combine them. We're going to combine the counts. 5.3 plus 2.4 is 7.7. And we keep the same name, 10 to the negative 7. Now there are some complications that can come into this. We can have 6.4 times 10 to the 9th plus 4.9 times 10 to the 9th. Do they have the same name? Yes, they do. So we're going to combine the counts. 6.4 plus 4.9 is 11.3. Correct? Times 10 to the 9th. But there's a problem with this right now. Can anybody tell me what it is? Yeah, there's 2 digits in front of the decimal point. We only want 1 digit. So we're going to move the decimal point over to make this 1.13. Did we make this number bigger or smaller? We went from 11 to 1. We just made it smaller, right? So if we made that number smaller, the power of 10 has to get bigger. Number smaller, power bigger. So this is 10 to the 10th. Yep. Yeah, if I move my decimal point here, the power of 10 has to change. If this number is getting smaller, the power gets bigger to move it back later. So how about 5.8 times 10 to the negative 8th plus 7.4 times 10 to the negative 8th. We have the same power of 10, so we can go ahead and add. What's 5.8 plus 10.4? 13.2 times 10 to the negative 8th. What are we going to have to change? Got to move our decimal point, so this will be 1.32. Does this power have to get bigger or smaller? Bigger. Yeah, this got smaller, so this has to get bigger. So negative 8 plus 1 is negative 7. Be very careful with those negative powers. A lot of people will be tempted to make that negative 9. But it's not. That's not bigger than negative 8. That's smaller. When you have a negative, when you make it bigger, negative 8 goes up to negative 7. What if they don't have the same power of 10? What if we have 7.2 times 10 to the 5th plus 9.3 times 10 to the 4th? Just like with our fractions, we cannot add them the way they're written, but we can change their names so that we can add them. We can give them the same name. Normally, what I would do is go to the higher power when I'm adding. So 7.2 times 10 to the 5th is going to stay the same. This, to become 10 to the 5th, the power got larger, so the number has to get smaller. The power got larger by 1, the number has to get smaller by 1 place space. This is now 0.93. So, now that they're the same name, 10 to the 5th for both of them, 7.2 plus 0.93 is 8.13 times 10 to the 5th. That's it. Subtracting. 6.4 times 10 to the 11th minus 4.8 times 10 to the 11th. Just like with addition, we must have the same power of 10. Here we have 10 to the 11th. So we're going to combine the counts. What's 6.4 minus 4.8? 1.6 times 10 to the 11th. We keep the same name when we add or subtract. So 5.4 times 10 to the 8th minus 4.62 times 10 to the 8th equals, well, we do have the same power of 10, so we can subtract. 5.4 minus 4.62 is 0.78 times 10 to the 8th. What's wrong with that? There's a 0 in front of the decimal point. We need a digit that's not 0 in front of the decimal point. So the decimal point has to move over one spot to become 7.8. Now this time, this number got larger, so the power of 10 has to get smaller. So 10 to the 7th. 8 minus 1 is 7. So we could have 9.2 times 10 to the negative 9th. Make that 9.21 times 10 to the negative 9th. Minus 8.9 times 10 to the negative 9th. We subtract 9.2. They do have the same power of 10. 10 to the negative 9th. So 9.21 minus 8.9 is 0.31 times 10 to the negative 9th. What's that going to become? 3.1 times 10 to the negative 10th. This number got bigger, so the power of 10 has to get smaller. Negative 9 minus 1 is negative 10. So those negatives keep haunting us. Why don't you guys try a couple? That's a positive one. So it's negative 9 minus 1 or negative 9 plus a negative 1. Yep. So 4.23 times 10 to the 7th minus 3.69 times 10 to the 7th. I want you to do that one. And then also please try 8.42 times 10 to the negative 8th plus 7.4 times 10 to the negative 9th. Try those two in your notes quick. First one, we're subtracting. 4.23 minus 3.69 is 0.54 times 10 to the 7th. Of course, that's not proper. What do we need to do?
Make it into an improper fraction.
No, we need to move the decimal point over. Make that 5.4 times 10 to the, does the power get bigger or smaller?
Smaller.
Smaller. Number got bigger, went from 0.5 up to 5. Power gets smaller, down to 6. Okay, down here, we're adding. Do we do 8.42 plus 7.4? Say no, why not? Currently, we have different powers of 10. Remember, we said we convert to the larger one, which is the negative 8. So we went from negative 9 up to negative 8. The power got larger by 1, so the number gets smaller by 1 place value. So this is now 0.74. Now we can add 8.42 plus 0.74 is 9.16 times 10 to the negative 8. How many had both of those correct? Okay. Good. Let's look at multiplication now. Let's look at 2.5 times 10 to this. Well, let's do this. When we multiply, if you recall, we do not have to have the same name. We could take 4 feet times 8 pounds. And even though we had different names, we could combine them. We're going to multiply the counts. 4 times 8 is 32. And then also multiply the names. Feet times pounds is foot-pounds. With fractions, we did not need the same name. We could have 3/4 times 1/5. And even though they were different names, it didn't matter. We're going to combine the counts. 3 times 1 is 3. Also combine the names. 4 times 5 is 20. So with our scientific notation, when we multiply or divide, we do not need the same power of 10. We can have 2.5 times 10 to the 8th times 3.1 times 10 to the 11th. We don't need the same power of 10. We do not have to have the same name when we multiply. We're going to do 2.5 times 3.1, which is going to give us 7.75 times, we also combine the names. 10 to the 8th times 10 to the 11th. What do we do with the powers? When we're multiplying, we add. So 8 plus 11 is 19. 7.75 times 10 to the 19th. Or we might have 4.1 times 10 to the negative 6th times 1.2 times 10 to the negative 4th. We don't need the same name, so we don't have to change our power of 10. 4.1 times 1.2 is 4.92 times 10 to the negative 6 times 10 to the negative 4 is negative 6 plus negative 4 is negative 10. Now again, it's not always that simple. We'd have 5.3 times 10 to the 9th times 4.6 times 10 to the negative 4th. I actually added a couple levels of difficulty here. The first one, 5.3 times 4.6. 24.38. So you can see a problem arising there. There's already 2 decimal point There are already 2 digits in front of the decimal point. Times 10 to the, well, 10 to the 9th times 10 to the 4th. We add powers, 9, or 10 to the negative 4th. 9 plus negative 4 is 5, so that's 10 to the 5th. Now we do still have to move our decimal point over 1 spot. This becomes 2.438. Number got smaller, power gets bigger, so 10 to the 6th. So 3.7 times 10 to the negative 12 times 6.2 times 10 to the 5th. 3.7 times 6.2 is 22.94 times 10 to the, well, 10 to the negative 12th times 10 to the 5th. Negative 12 plus 5 is negative 7. Are we done? No, got to move the decimal point. So 2.294 times 10 to the negative 6. This got smaller, so this has to get larger by 1. Negative 7 plus 1 is negative 6. Any questions? It is what it is, right? Well, what if we go to divide? So we have 2.438 times 10 to the 7th divided by 5.3 times 10 to the 4th. Well, we divide the numbers. 2.438 divided by 5.3 is 0.46. Times, well, we're going to combine the names. That's 10 to the 7th divided by 10 to the 4th. When we divide, we subtract the powers. 7 minus 4 is 3. Now, of course, we've got to adjust that decimal point, so we're going to have to adjust the power. This becomes 4.6 times 10 to the number got larger. Power has to get smaller by 1, so 10 to the 2nd. 1.728 times 10 to the negative 8th divided by 1.44 times 10 to the negative 3rd. 1.728 divided by 1.44 is 1.2 times 10 to the negative 8 divided by 10 to the negative 3rd. So negative 8 minus a negative 3. Negative 8 plus a positive 3. You are correct. 10 to the negative 5. How are we doing?
Good.
Good? Having fun yet? No? At least you're honest. What's that? 2.4 times 10 to the 7th to the power of 2. Now we could write this out as 2.4 times 10 to the 7th times 2.4 times 10 to the 7th. But what fun would that be? Don't answer that. The power of 2, we can apply it to the count and then also apply it to the name. So 2.4 to the 2nd power is 5.76. 10 to the 7th to the 2nd power is 10 to the 14th. When we have a power to another power, we multiply the power. 7 times 2 is 14. 1.2 times 10 to the negative 5th to the power of 3. Well, again, 1.2 to the 3rd power is 1.728 times 10 to the negative 5 to the 3rd power is 10 to the negative 5 times 3 is negative 15. we might have, oh, what do I want to do here? 3.4 times 10 to the 7th to the 5th power. So we're going to take 3.4 to the 5th power. $454.35424. Times 10 to the, 7 times 5 is 35. But we're not done yet. We've got to move the decimal point over to here. 4.544 is probably what we'd probably round that off after a few decimal places. What has to happen to our power of 10?
Go down.
This number got smaller. It went from 454 down to 4. How many decimal places did it get smaller?
2.
2. So this has to get larger by 2. So 37. Okay, I think it's time to let you guys practice. I need a couple minutes to pass back your tests anyway. So in your book on page 130, exercise 2.6. It is problems 59 through 81, the odds. And on page 133, exercise 2.7, problems 1 through 23, the odds. Now there's something in there called engineering notation. We have not had time to talk about yet. So if you hit that, if you can figure it out from looking through the section, that's great. Otherwise, we'll talk about that a little bit tomorrow.